So hello everyone. Today we are going to discuss the next question in this top interview 150 series, that is remove element. So let's go and try to understand this. So this is our question, and this question is saying that we are given an integer array nums and an integer val. Remove all occurrences of val in nums in place. The order of elements may be changed. Then return the number of element in nums which are not equal to k. So what we have given? We have given an array and an integer val. So what we have to do is we have to remove all the occurrences of val from this nums array. And we have to perform this operation in place. That means we do not have to take any extra array for performing this operation. And after the final result, the order of the element might be changed. Then what we have to do, we have to return the number of element in nums which are not equal to val. So basically we have to return those elements in nums which are not equal to this value val. Okay. And it is saying that consider the number of element in nums which are not equal to val to be k. To get accepted, you need to do the following things. So there are basically two conditions what we have to do to make our solution get accepted. So first one is change the array nums such that the first k elements of nums contain the elements which are not equal to k, which are not equal to val. The remaining element of nums are not important as well as the size of nums. So what it is saying, it is basically saying that when you will convert this into a final solution, basically the first k element inside the nums should be those elements which are not equal to this value val, and the rest of the elements you can put any of the element in place of them, so it will not basically affect the actual solution. After that we have to return k, and after the final solution, that solution will be tested against this custom judge. So this judge will test your solution with this following code snippet. So it is saying that we have given an integer nums. Okay, this is an input array, and this is the value which we have to remove. And this is the expected nums. Expected nums is the array which is the final array after removing all the val occurrences from this nums array. And basically it is sorted with no values equaling val. So basically it do not contain any value that is equal to val, and it is finally sorted. And after that it will check against two assertions. So assertions are basically assumptions that are made, and if these assumptions are true, then only a solution get accepted, otherwise it will be rejected. So the first assumption is that is equal to expected nums dot length. So k is basically k is going to call our implementation of this method, and k is basically the number of element in this nums array excluding this value val. So it will check this condition that if k is equal to expected nums dot length, and if this assertion is true, then it will check for another assertion, that is nums of I equal to expected nums of I. And if these both assertions are true, then only our final solution will get accepted, otherwise it will be rejected. So let's try to understand it with the help of this example. So let's take this example. So this is our nums array, and the element inside it are 1 0 1 2 2 3 0 4 and 2, and val equal to 2. This val is representing that, and basically we have to remove all the occurrences of this val from our actual nums array. So the first naive and the brute force solution that comes into our mind is we will take an extra space which is basically equal to this to the size of this nums array. So let's take this, and what we will do, we will simply take a pointer here and a counter here. So what this counter and this pointer will do, so first it will traverse this whole array num, and it will check for each and every element that whether this element is equal to this val or not. And if this element is equal to val, it will simply increase the pointer without performing any operations. Otherwise, what it will do, if this element is not equal to this val, it will simply take this element, put this inside this dummy array, and move this pointer and this counter both. So let's start. So first it will check whether this 0 is equal to 2. Condition is false. Simply take this 0, put it here, increase both the pointers. Again, it will check for 1. 1 is not equal to 2. Simply put it here, increase both the pointers. Then it will check for 2. Now, this is not counted, it is I. Now, as we can see, this 2 is equal to 2. So that is the different condition. In that case, it will only increase this pointer. It will not increase the counter. It will only increase this pointer. So this pointer will come here. Again, this 2 is equal to 2. So it will again increase this pointer. Now this 3 is equal to 2. Condition is violated. 3 is not equal to 2. So basically it take this 3, put it here and increase both the pointers. Now it will check for 2. 0 is not equal to 2. Take this 0, put it here, increase both the counters. Then 4. 4 is not equal to 2. Put this 4 here, increase this counter and increase this pointer. Then it will check for 2. 2 is equal to 2. So simply it will increase this counter I, and it will not increase it further, increase this counter further. Now as this pointer limit is exhausted here, as it crosses the actual length of this nums array, so its limit is exhausted, so it will stop here and terminate out of the loop. Now if you will see the number of element now inside the dummy array is not including this value 2, and these number of elements are 1 2 3 4 5, and this 5 is basically equal to this position of counter now. So this will be the final result. We basically have to return this counter from here, because this counter here is representing the actual number of elements that is inside this dummy array, which excludes this value well. But now we can't keep it as it is, because this is the dummy array and it will this assumption is made against this nums array. So what we have to do, we have to traverse from this array and we have to take all these elements one by one from this dummy array and dump these element into this nums array. So these all elements will come here. So this is the brute force solution. Now if we will analyze the time complexity and space complexity, then as we have to traverse all the element of this nums array, so basically the time complexity is equal to the size of this array, that is order of n, where n is nums dot length. And if we will see space complexity, then space complexity is also order of n. As to perform this operation, basically we are taking a dummy array which is equal to size of this nums array. So this is what our time complexity and space complexity. Now this time complexity can't be reduced further, as basically we have to traverse all the element, as we have to perform operation with each and every element. So this time complexity can't be reduced further. But here we are taking some extra space, that is order of n. So basically we have to reduce this space. We will design some algorithm that will reduce this space from order of n to order of log n, or to constant space complexity. So let's try this. For this, we are going to take this same example, that is nums equal to 0 1 2 2 3 0 4 2, and this val that we have to remove is val equal to 2. So as we have to reduce the space complexity, so here we are not going to take any extra space. We will actually going to solve this question using two pointer approach. So basically we will take two pointers here. And to visualize how it is working, basically I'm taking a new array. Basically it is not the newer array, it is the same array as nums. I'm just taking it to visualize how basically it is working, to avoid confusion. So there we are not actually taking any extra array in this array, just for visualization purpose. So now our two pointer will work in the way that if I equal to j, if I is equal to j, means these both pointers are at the same position, and if this array of this nums of j is not equal to val, nums of j is not equal to val, then basically we have to increase both pointers because we are not going to change this position. As this is not equal to val, basically we do not have to remove this element, and as these both pointers are at the same location, so basically we will keep it as it is. So we will keep this as it is and simply increase both the pointers. So in this case, basically we will increase both the pointers without making any change. Now again, this I equal to j, and this nums of j is, that is 1, is not equal to 2. So we will simply increase both the pointers and keep it as it is. Now this I equal to j and nums of j is now equal to this value val. So here there is a there is a change in the condition, as this nums of j equal to this value, that is 2 equal to 2, and these both pointers are at the same location. So basically at this time only we have to increase this j pointer. So we will increase this j pointer until we will not get any other element to be replaced to this place, because basically we have to remove this element in place and we have to put any other element in this place of 2, as we have to remove all the occurrences of this value 2 from this nums array. So we will simply increase this j pointer. Again, this nums of j equal to 2, so we will simply increase this j pointer. Now I is not equal to j. As we can see, I is not equal to j, and also this nums of j equal to uh, this not equal to this val. This nums of j is not equal to this val. So what we will do, we will simply put this nums of j in the place of nums of I. So this 3 will actually replace this 2. So 3 will come here at this place. After that, what we will do, as this place is now filled, so we will increase both these pointers. So I will come here and also j will come here. Now again we will check that this I is not equal to j, and this nums of j is basically not equal to val, as 0 is not equal to 2. And here, as we have this 2, so we have to remove this 2. So what we will do, we will simply put this j and nums of j in place of this nums of I. So basically we will put it here. So this 0 will come here. After that, we will simply increase this I pointer and also this j pointer. Again, if we will see, this I is not equal to j, and this nums of j is not equal to val. So what we will do, as this place is vacant, as this element is already filled at the preceding position. So what we will do, we will simply take this element and put it in place of I. So we will put it here 4, and then increase both of these pointers I and j. Now as I is not equal to j and I is not equal to j and nums of j equal to val. So what we have to do, we basically increase only this j pointer. So j will come here. Now as this j has exhausted, as it crosses the limit of the length of this nums array, so here we will came out of the loop. So this is how our algorithm actually work. And now if we will see that this I is at this position as per the indexing, if we will see, then this is the fifth position where this I resides at the last. And if we will see, then that the number of element finally in this nums array will be 0, 1, 3, 0, 4, that is 5 elements. So basically these 5 elements are representing by this I pointer. So at last we will simply return this I pointer. So this is basically the final result, that is the value k, and k is basically equal to the number of elements in this nums array, excluding this value val equal to 2. So this will be your final array. So let's try to code this solution. Let's go and try to code this solution. So what we will do, basically we have to use a loop here. We will use a while loop, and this while loop will move till the position this j is less than the length of this nums array. So until the time this condition is violated, this loop will move forward. And when this condition is violated, it will terminate the control, and the control will come out of the loop. So let's code this. So we have to take 2 pointers there. Initially, these both pointers are should be at 0 index. After that, this loop will run till this condition is violated. Now, basically, we have to check whether I is equal to j, means these both pointers are at the same place or not. So if I equal to j and nums of I is not equal to val, sorry, it is j because we are checking for j pointer. Then in that case, basically we simply have to increase both the pointers without performing any operation. So we will simply increase both the pointers. Else, if I is not equal to j, and also this nums of j is not equal to val, in that case, what we are visualizing here in this case, that I is not equal to j. So what we have to do, we basically have to put this element at j position at this I position. So we will simply do this. Nums of I equal to nums of j, and simply increase both the pointers. Else, we left with only one condition, that in case this nums of j is equal to val, equal to actual value. So what we will do in that case, we will simply increase the j pointer until we will get the element which is not equal to the value val, and to replace this actual value val. So what we will do, we will simply increase this j pointer. After that, what we will do, we will finally return I, which represents the length of the array after removing these value val elements. Okay. And basically here we are also going to describe some edge cases, that is edge points, that is if nums dot length equal to 0. In that case, basically we simply return 0. So now let's try to run this, and it is passing all the test cases. Let's try to submit this, and it got submitted. So that's all for the today. Thank you.